Okay, welcome to this video where I'm going to discuss using pipes. I'm going to be using the built-in MT-Cars data frame, which is part of R, and if you look over in the help pane, you will see that there are 32 cars, and there are 11 attributes, 11 columns associated with each car. These are all numeric quantities, although some of them are clearly factors, such as transmission type, which is either 0 or 1. The data is very simple, which is good because it allows us to focus on learning what the pipes are doing without dealing with some complicated data. To interrogate the data frame, if I wanted to extract all the rows where the miles per gallon is greater than 17 and the transmission type is manual, I could use a command line like this. This is classic bracket notation. It's what R students learn usually pretty soon in any R class. So we have this data. What I don't like about this is that I have to prefix each column with the name of the data frame and the dollar symbol. As an alternative, R provides a native function called subset, which allows us to specify as the first argument the name of the data frame we wish to inspect, and then followed by any logical clause that we want. So this command is the same as this command in terms of the results. Some people favor subset over the bracket. It's entirely up to you. This is where dplyr comes in. This is where I feel that it provides a really nice alternative. First of all, if you go to the help page for dplyr, if you look at the bottom, there's a web page for this. And the web page gives you a breakdown of all the verbs. Well, not all of them, but most of the verbs that are in the package. Now, they use the concept of verbs because there are certain activities that are common to data frames, such as selecting columns, filtering cases out, summarizing things, arranging them, sorting them, and so forth. Another good thing about dplyr is none of the commands collide with anything in native R. So if I want to use the filter function, which allows me to filter a data frame based on some criteria, I give it the name of the data frame as well as the logical phrase, which looks pretty much like subset. The results I get back are the same. All right, the pipes. What's going on here with the pipes? If you've never seen this before, I admit it can be confusing. And we have this character. It's percent greater than percent. And what you want to think when you see this is that it's routing data from one command to the input of another command. You would read this command from left to right. So if we type MT-Cars and we don't do anything else, we would get the data set back, the contents back. If we put a pipe character here, this says, hey, take the output from MT-Cars, pipe it or route it into the input of filter. Notice here that we do not then have to supply the name of the data frame as an argument. So this is the same as this. Now what I like about the pipes is that I can route, or I can create multiple routings, multiple pipings, if you will, by using this character. So I'm filtering out all the cars where the miles per gallon is greater than 17, transmission types equal to 1. I pipe that into group by cylinder. Now, if you look at the cylinder column in the MT-Cars data frame, you will see that cars are either 4, 6, or 8 cylinder. We may want to investigate the relationships of MPG across those cylinder groups and figure out what the best gas mileage might be. The pipe function, and we can put this all on one line. In other words, I could do it like this. I can press return. R is pretty flexible in this regard. So I take the output from MT-Cars, pipe it to filter, then pipe those results to the group by, where I'm grouping by cylinder, and then for each cylinder group, I want to summarize the average MPG. So if I do that, I get a table back. Notice that the 8-cylinder cars are not represented here because none of those evidently have a mile per gallon of greater than 17. And if I wanted to make this more complex, it's easy to just change this command line. So in this particular case, I'm going to group by cylinder and gear, and then look at the overall mean MPG for each of those groups. So this is a slightly more complicated table. And the way to interpret this is that we have 4-cylinder cars, and within 4-cylinder cars, we have cars that either have 4 gears or 5 gears. Now, if you notice, we don't really have the average MPG in a specific order, and we can use the pipe functions to deal with that. So I'm going to expand on this command by adding another pipe. This is the same command as I just typed, or just ran rather. I pipe the output of that into a range, which is going to sort the average MPG. I'm going to round it because I want two decimal points, 2 digits after the decimal points. And notice I have the same thing, except now the data is sorted. I like this because I don't have to commit to a specific set of code. I can keep typing these kinds of things. I can type over them. I can rethink what it is I'm trying to accomplish. And it's for this reason I think pipes are better. Now, you may not agree, but let me show you what you would have to do if you did it the old way using the native R constructs. So the first thing I might do is filter out all the cars, again, greater than 17 mpg of a manual transmission type. And then I would stash that information into a new data frame, mtcars.2, for example. And then if you look at these results, you can aggregate them using the aggregate command. So I'm going to look at the MPG as a function of the cylinder and gear groups. And I'm going to create an aggregation table. Okay, mtcars.2.ag. Notice that this table looks similar to the tibble that we got back from the dplyr pipes. I want to sort this just like I did previously, and so I have a table and a data frame rather, and I can use the order function to sort this. And I get something that's identical or pretty similar to what I got previously. This might be nice if you're learning R and you want to slow things down to a step-by-step approach. Okay, the pipes, let's just keep extending this example. They're good for generalizing activities. In the above example, we did an aggregation. I wanted to prove to you, or show you rather, that ggplot will accept the output from a pipe as input. And so in this particular case, I want to create a histogram of the MPG for the cars. And this histogram looks, it's okay. There's only 32 rows in the data frame, so it's not a particularly dense histogram. But I want to point out a couple of things. First, that if I type the data frame and the pipe character, ggplot will accept the input. Now notice something here. The aesthetics here on the x-axis is the miles per gallon. So what we see is that we only have a few cars that have better than, say, 25 miles per gallon. Now what I wanted from this, notice I'm using the fill aesthetic. What I would like to do is have some colorization in this histogram dictated by the cylinder group. So remember that there's cars that have either 4, 6, or 8 cylinders. And I would like to see that reflected in the histogram. The problem is that it didn't do anything, apparently. There was no effect here. This is a subtlety with ggplot. And I'm pointing it out here. It doesn't really have anything to do with the pipes, but I'm pointing it out here because it is important. What I need to do is officially turn cylinder, if I'm going to use it as a fill aesthetic, I need to turn it into a factor. So I'm doing that. This second version does precisely that, right? And when I run this command, okay, notice now things are working. The histogram is the same as before, but there are colors being applied based on whether the observation is a 4, 6, or 8 cylinder car. Now, if you look, you notice that most of the better cars, better in terms of gas mileage, are over here. They have 4 cylinders, and the ones with the worst are in the blue, the 8 cylinder. Okay, as a final example, I want to show you how you might use the pipes to create the factor on the way to actually generating the plot. In the example that you just saw, you notice that when I called the fill aesthetic, I used the factor function to encapsulate the cylinder variable. Another way to do that is use the mutate verb that's available to us from the dplyr package, and I insert that after MT cars. So I'm piping the output of MT cars into the input of mutate, where I turn cylinder into an actual factor. So by the time it hits, by the time it is passed to the input of ggplot, it is already an official factor. So if you look at the output, you're not going to see anything different. It's basically the same plot. But what is different is I can create factors using pipes. Now, you can combine the verbs from dplyr in any way that you see fit or see appropriate. Obviously, you want to do it in a way that makes sense to you and in a way that makes it easy for you to figure out what you did if you come back to your code a day or a week or a month later. So I'm going to wrap it up with this. Thank you for watching. I hope you've learned something. Make sure to look at the notes section of the video so you can download the code. Thanks.